This conference will now be recorded.
Hello everyone. So in today's class, we'll discuss previous year's questions from JEE Mains, and that is based on the chapters coordination compounds. Here we have the first question. Here is mentioned in the right hand side, as you can see. The total number of stereoisomers for the complex. The complex is already given. So this is the complex chromium ox2 ClBr. Now here we can see total 3 different types of ligands are there. Cl minus, we have Br minus, and there is ox. But what is ox, that we have to understand. Ox is basically this one, oxalate. Oxalic acid is CO2H, CO2H. But if I omit the hydrogen, it will be negative charged carbon, oxygen. Okay, so this is known as oxalate, and it can bind to metal like this. So we can compare this ligand as if it is AA type, like this, which is binding with metal in this way. Now there is total 2 ox. That means if I write the formula for this complex in general way, what I mean by general way, because if you consider the general formula, you can apply the same type of question for other complex also. Here we have this type of bidentate ligand, which is ox, and that is symmetric because both side of the binding side, that is similar. It is not one side there is oxygen, another side we have different atom. Both sides similar, so it is symmetrical bidentate. So I am writing it as AA whole 2, and Cl as if it is another monodentate ligand, which is B, and Br is suppose another monodentate ligand. Now why I am writing it in this way, and there may be any charge, that is not important. Why I am writing it this molecule? Because suppose in place of chromium you have any other metal, in place of ox you have any other symmetrical bidentate ligand, and answer will be same. Here it is important to understand the general formula so that you can also apply the question for other formulas. Here now we will write the stereoisomers. Now AA, as it is binding to metal from 2 sides, now the possibilities are it can bind with the metal in this way. Now 2 sides are left, obviously it will be octahedral because total binding side 6. Here I am placing B and here I am placing C. Now another possibility is if I am writing B and C, now see it is different. Okay, one thing I have to change. When I am placing B and C in C's position, the AA, that is 2A we have total, it will be like this. Now if you want to get the octahedral arrangement, if you want to understand, it is simply like this. So these two, their relative configuration, it is trans. And in this case, as the angle between these two 90°, in this case it is 180°, in the second case it is 90°, so it is cis. Now in the trans, whether so these two geometrical isomers are possible, but is it the only possibility? Is 2 is the answer? Actually 2 is not the answer, because here if you cut the molecule by this plane, which is perpendicular to the plane where all the 4A present, if you cut the molecule in this way, both are actually same, so this is optically inactive, OI. But C is, you cannot find any symmetrical plane, so if you consider its mirror image, then these two are non-superimposable to each other. So that is why here we will get 2 optically active isomer. One will be D, another will be L. So from Cs basically we are getting total 2, and from trans it is only 1 because it is optically inactive. But in the second case we can get mirror image, so that is why 2 more possibilities are there. Now 2 plus 1, total number will be 3. So option B will be the correct option. Sorry. So option B is the correct option, as you can see here. And you can also apply the same discussion. You can also apply for another type of complex where you have 2 symmetrical bidentate ligand like this and any other 2 monodentate ligand. Next question. Which of the following complexes will exhibit maximum attraction to an applied field? Now the question is basically asking in which case there will be maximum number of unpaired electrons, because when the maximum number of unpaired electrons, then the spin only magnetic moment which we calculate from this formula, that value will also be high, because when n increases, this total magnetic spin only magnetic moment, that also increases, and that means the maximum attraction to an applied magnetic field, right? So the question is basically asking you have that in which case there is maximum number of unpaired electron. But if it is directly asking that, that will be very flat question, simple question. But it is asking in a twisted way, so that first you have to understand the meaning of this question, then actually you have to solve it. Now the first complex, here we have water, 6 water attached to Zn. Water is neutral, so here the metal atom is basically Zn2 plus. In the second case, CO2 plus, because again we have water. Then the third case, here we have En, but see, En is ethylene. This is the structure of En. Ethylene diamine basically. Okay, so here these two are the binding side to the metal, and we have total 3 En, and En is basically strong field ligand. These two are weak field ligand. Water is weak field ligand. Next, fourth one is also weak field. That is water is again we have. This is CO3 plus. Here we have nickel 2 plus. Now for each case you have to find what is the number of unpaired electrons. Now when it is Zn2 plus, it is basically 3d10 4s2, but because of 2 plus charge it is only 3d10. Now when it is 3d10, basically n value will be 0. Now for the next one, when it is CO2 plus, it is 3d7. Now we will see the splitting, octahedral splitting, 3d7 weak field ligand. So first you have to place all the electrons like this, and the extra electrons, 2 more extra electrons, it will be like this. So here n value is total 3. Come to the third one. Here CO is 3 plus, but remember it is strong field ligand, and 3d6. So as it is strong field ligand, you have to do pairing. So it is T2G 6 EG 0, not like the previous one. Here number of unpaired electrons 0. And what about the last one? Nickel 2 plus is 3d8. Here weak field. So number of unpaired electron, it will be only 2. It is T2G 6 EG2. But whatever is the configuration, even if you don't write it, that doesn't matter. You just have to place all the electrons so that you can understand the number of unpaired electrons. Now in which case the number of unpaired electrons maximum, it is this one, right? That is cobalt 2 plus. So that is why this should be having the maximum attraction to an applied magnetic field. This is the correct option. Okay. Be careful about the strong field ligand and weak field ligand. So here it is strong field ligand. The other 3 weak field ligand. We have to match list 1 with list 2. Here in the list 1 we have some complexes, copper complexes with amine, then titanium with, sorry, it is H2O, then Fe with cyanide ligand, and nickel with fluoride ligand. And in the right hand side, that is in the next list, we have all the CFSE value. You have to calculate the CFSE for all the 4 complexes so that you can understand which is the correct option. Now Cu with amine, right? Cu, here the oxidation state is 2 plus because amine is neutral ligand, and when it is 2 plus, it is basically 3d9. And when it is 3d9, if you place all the ligands, electrons, you will see here CFSE value, that will be total 6, that means minus 0.4 into 6 plus total 3. You have to multiply with 0.6 with 3. So as a result, what we will get is minus 2.4 plus 1.6. So ultimately it is minus 0.6. That means it is matching with the first one. So A should be matching with any of these 2 options. Now what about the second one? In the second case, we have titanium 3 plus. Now titanium 3 plus, it is 3D1 system. Okay, so as it is 3D1 system, there will be only del O value possible is minus 0.4, because there will be only 1 electron in T2G like this. So it is simply minus 0.4 into 1. So overall del O value is also this. and that you can find here. So B is matching with 4. Now B is 4. That is that you can get only in option 1, isn't it? So see, until this point, that is, even if you solve the question up to this point, then also you can choose the correct option. But I'll also show you all the other values. Iron with Cl6 3n minus. Now as it is negative ligand, here oxidation state is 3 plus. Now when iron is 3 plus, it is basically 3d5. Now 3d5 means if you place all the electrons, remember cyano is strong field ligand, so it will be like this. So minus 0.4 into 6, and there is no electron in Eg. Sorry, 5 electron, not 6. 5 electron. So this is the del O value. So it is matching with C is matching with 2. So see, that is also present in option 1 because we have already chosen option 1 is the correct option. We are just doing this extra work so that you can wholly understand the question. Okay. And then we have D3, only 1 is left, but still we'll do the calculation so that we get the full explanation. Ni F6, that means total 6 negative charge. Outside there is 4 negative charge. That means the oxidation state over nickel, it will be 2 plus. Now when nickel is 2 plus, it is basically 3d8, and we have weak field ligand. So first you can place all the 5, sorry, again I'm saying ligand, it is actually electrons. Just place all the 5 electrons, single, and then 3 extra electrons like this. So it will be minus 0.4 into 6 plus 0.6 into 2. So minus 2.4 plus 1.2, it will be minus 1.2, which is D is matching with 3. That means all these are indicating option 1. Now you can see all the calculations in a single table. This is D9 strong field, then strong field ligand, weak field ligand, again strong field ligand, and this is also weak field ligand. Here it is 0.6, then 0.4. So these are our calculations. 0.4, the next one minus 2.0, and this one. So option 1 is the correct option. Fine. Next we have assertion reason type of question, and here assertion is saying that COCl NH352 plus. This complex absorbs at lower wavelength. Now wavelength, it is inversely related to energy. That means when it is lower wavelength, that means it is higher energy of light with respect to this one. Now both are cobalt. What about the oxidation state? In the second case, it is 3 plus, and ammonia, water, both are neutral. That means here also oxidation state is 3. In the first case, we have one negative ligand. Ammonia is neutral. 2 plus is mentioned outside. That means here also oxidation state is same. So in both complex, with respect to oxidation, we cannot say anything. Now look at the ligands. We have 5 ammonia. Here also we have 5 ammonia. So this is again common. But here you have Cl. Here you have water. Now among these two, which one is strong field? Obviously water is strong field. Water greater than Cl. So that is why when everything is same, rest of the things are same. Only these two are different. That means where water will be present, in that case del O value will be high. So it cannot be at lower wavelength, it will be at higher wavelength. So the assertion statement is not correct. Now what about the reason statement? It is saying it is because the wavelength of light absorbed depends on the oxidation state of metal ion. Now that is also true. Suppose you are comparing two complex. In both cases, ligands are same, but oxidation state is different. So where the oxidation state is high, suppose in one case oxidation state is 3 plus, another one oxidation state is plus 1. So in this case, CFSE will be high. That means wavelength, energy dependent means wavelength is also dependent. So wavelength is dependent on that, but it has nothing to do with the assertion statement, because in the assertion statement, even if the assertion statement is right, reason cannot be the correct explanation because their oxidation state is same. Reason Separately, individually, it is correct. Wavelength or energy is dependent on oxidation state. Higher oxidation state means the gap between T2G and EG, that will increase. That means energy is high. That is fine. But oxidation state is same in both the complexes. And second point is here assertion itself, the statement is wrong. So A is false, R is true. Okay. So here you can have a look in the spectrochemical series order and just look at these two, Cl minus H2O. H2O is far greater. I'm not saying that H2O is strong field ligand. Both are weak field ligand, but still if you compare two weak field ligand, that is when it will be required to compare. You have to take the help of spectrochemical series. So H2O is coming much before than Cl. So obviously where water is present, provided rest of the things are same, then obviously the second complex will be absorbed at higher energy. Since water is a strong field ligand compared to chloride, CFAC is higher for the second complex, as you can see it is mentioned, so it will be absorbed at lower wavelength because these two are inversely related to each other. So assertion statement is not correct, it is false, but reason is true. Option 1. Next we have to find IUPAC name. So this is that is another type of question you can get from this chapter, where sometimes complex will be given, you have to choose the correct name, or sometimes name will be given, you have to choose the correct formula. Both are important. Here we have K3, then inside the third bracket cobalt C2O4. Now C2O4 is basically oxalate ligand. Remember the first question of today's class, we have already solved it, and this is actually oxalate, or you can write it as same C2O4 2 negative. Fine. So C2O4 2 negative, and you have total 3 oxalate like this, CO ox 3 K3. That means if you remove K3, there will be total 3 negative charge. Now 3 negative charge, and for each oxalate it is -2 charge. That means when it is 3C2O4, total negative charge will be -6. So -6 outside 3 minus. So the oxidation state of cobalt, it must be +3. Okay. So CO3 plus, and here in the complex, this is the positive part and this is the negative part. So what I'm actually trying to say, take a very simple compound, sodium chloride. So how you write the name? Sodium first, chloride first. So the positive part we always write first, then negative part. So for complex compounds also the rule is same. Positive part you have to write first. And if you look at the options, in all the cases, first it is all the 4 options are starting with potassium. So that will not help you to choose the option. Next you have to focus on how the name is ending, because when you are ending the anionic part, suppose you are ending here chloride, that means sodium, it is just like sodium, normal sodium also we pronounce it like sodium, but when it is you are ending with chloride, it is chloride. Similarly here also it will be not ending simply as cobalt, it will be ending as cobaltate. So any of the option 1 or 3 will be correct. These two you can cancel because it will not end with cobalt, it will be cobaltate. But how to choose between 1 and 3? What is the difference? Here it is mentioned as tris oxalate, but here it is mentioned as trioxalato. Now tris you don't need to use there, tri is enough. Normally we use bis or tris, though it is true that bis tris is just analog of bi or tri, which means 2 and 3. But when you use bis and tris, when already there is some in specific cases we use it. For example, ethylene diamine, that is EN, we use bis because in ethylene diamine you are already using the term di. Sorry, it is di, not bi. You already using ethylene diamine. So you cannot write, when you have total 2 ethylene diamine, you cannot write it as diethylene diamine. Then you have to use bis. But here that problem is not arising. When you are pronouncing oxalate, or then There is no di or tri. So that is why directly you can write trioxalato. And don't end it with oxalate. It will be ending with oxalato. All the rules are discussed in detail in the actual chapters if you watch those videos. So it will be potassium trioxalato cobaltate 3, because that is the oxidation state of cobalt. So this should be the correct option. Next question we have, cobalt chloride when dissolved in water. Suppose you have taken cobalt chloride, you are dissolving in water and it is forming a pink colored complex X, which has octahedral geometry. So here the informations whatever you are getting from this problem, not just any descriptive problem, whenever you will face, better you write the informations in rough page like this. So X is octahedral and it is pink. So that why I'm saying so, because if you write all the informations in this way, every information you can see all together. This solution, when you are treating with concentrated HCl, now you are treating it with concentrated HCl, you are getting deep blue complex Y. So this is blue and Y has Z type of geometry. Z is the geometry. So you have to find all this. Fine. Now X is cobalt chloride and you are treating it with water. That means cobalt chloride, when treated with water, all the chloride will be replaced and that place will be taken by water. So if you look at the options for X, all the chloride will be removed and cobalt chloride is basically, if you consider the charge, it is 2 plus. So it will be either 1 or 2. Now what about Y? When you are treating it with HCl, basically now H2O ligands that will be again replaced by Cl. Now which one is correct? Is it COCl4 2 minus or COCl6 3 minus? Actually it is tetrahedral complex, not this one. It is tetrahedral. Fine. But why it is tetrahedral? If you ask the question, basically for tetrahedral, the splitting if you consider, that is del T and del O, if you compare these two, del T is basically lesser than this. So as this is lesser, so tetrahedral geometry will be preferred. So this should be the correct option. So here the equations that will be responsible, I am just writing that. First there will be formation of this, which is basically X. And now you are treating it with chloride ion, which is coming from concentrated HCl. There will be equilibrium. Why I am saying equilibrium? Because you can again switch to the opposite direction. Suppose you are treating it concentrated HCl. If you are again treating it with water or if you are diluting it, then because of this equilibrium, you can again get back the original complex. So after treatment with concentrated HCl, you are getting COCl4 2 minus and all the 6 water now outside. Okay, so this will be the equilibrium, and because as delta is smaller, so this is not formed, but COCl4 2 minus is formed. Fine. Next question is, what is chlorine cobalt chlorine bond angle in a FAC isomer? Now FAC and MAR, these two isomer, they just remain, that is, they occur together, that is pair of isomer. And this type of isomerism we observe in the metal complex of type Ma3B3. So that is 6 is a coordination number. You have 3 monodentate A ligand and 3 monodentate B ligand. So whenever you will have this type of general formula, not just this one as it is given in the question, whenever you will get this type of formula, you will always see that FAC-MAR isomerism is possible. Now FAC-MAR isomerism, what is the difference? If you look at these options, okay, let me write it as capital A so that you can compare with this picture. So this is the general formula Ma3B3. Here I am writing with capital AB. So in the FAC and in the MAR, the basic difference is, in FAC, if you connect all this, you are getting a triangle. And see, in this triangle, just consider any 2A. It is always 90 degree. If you if you are choosing these two, it is 90 degree. If you are choosing this A and this A, that is also 90 degree. If you are choosing this A and this A, that is also 90 degree. So whatever you choose, the angle is always 90 degree for fact. And that is also same if you are joining this 3B, you are again getting a triangular face. So as you are getting a face that is just outside this octahedral geometry, it is not something inside. If you consider this two triangular plane, it is not cutting the geometry, it is outside. So it is facial, fac. And what is mar? Mar is basically the short form of meridional. Mar is, see the difference. Here if you are joining these 3A, you can also do it for B. Then the triangle that you are getting, this face, this plane, that is as if cutting the octahedral geometry inside. So this is actually mar. Now, in case of mar, there is basically two different types of angle. If you are considering these two A, the angle is 90 degree. But if you are considering this and this A, now there is another type of angle, which is 180 degree. So for fac, there is only one angle possible. But for mar, you are getting 180 degree as well as 90 degree both. This is the difference. So what will be the answer? Obviously, only 90 degree will be the correct answer, isn't it? Chiral complex from the following is En means ethylene diamine that you already know, still it is given. Here we have some cis trans complex. Now cis and trans option 1 and 2 both are actually same complex, only cis trans is difference. Option 3 again we have cis PtCl2 but now it is not En, it is ammonia and there is no charge outside. And the fourth one it is cobalt complex. If you consider Pt, these two, option 1 and option 2. Now for option 1 and option 2, here in case of trans, if you cut the molecule in this according to this plane, which is perpendicular to this square plane, then both sides are same. So this is optically inactive. This is achiral, right? But if you consider this one, that is cis, there is chirality possible. What about option 3? That is PT. It is cis and total 2 ligands. That means 4 coordination. And as it is cis, I will write it like this. But see, for cis and square planar complex, you will obviously you can easily understand this complex. There is a sigma plane present that you can easily find. Whether you cut the molecule along this line or actually along this line, if you cut, both sides will be same, right? That means this cannot be chiral. Even if you consider this plane as if a plane, then also you can consider as if there is a molecular plane, that is also a plane. So this molecule cannot be chiral. And the last one is trans, where we have 4 ammonia and 2 chlorine. So as it is trans, so I will place both the chlorine like this. And here you will have 4 ammonia. If you are cutting the molecule, both are half same. So this is having sigma plane. So only this one we are seeing, there is a chance that it will be chiral because it's mirror image. If you consider its mirror image, it will not be superimposed. So that is why this will be the correct option. Match list 1 with list 2. We have list 1, some coordination complex. In list 2, we have wavelength. Now, don't think that it is very difficult that you have to do any calculation. No, you don't have to do any calculation. But important thing we have to notice here, what are the types of ligands? So in the first complex, that is in case of A, we have chlorine and we have ammonia. Oxidation state is 2+, right? In case of B, again we have oxidation, here it is 3+, and we have only one type of ligand which is NH3. Then we have C, where we have cyano ligand and oxidation state is 3+. In case of D, oxidation state is 2+, only one type of ligand. Now in which case you have the strongest ligand present? It is obviously the cyano ligand which is present in C. So this should be having highest, I am writing max energy. Now max energy means minimum wavelength, and it is matching with minimum wavelength is 310. That means C should be associated with 1. C associated with 1, that you can get only in option 2. See, if you are getting this type of situation, if it is arising, then you are lucky. The first complex you are just trying to match and you are getting the answer, because C matching with 1, that is present only in option 2. But we will also see the other complex. So it is Cn. The next strong field ligand is ammonia, though it is not so strong like Cn. But next we have to consider. Okay, another point you can also do. This is the maximum wavelength, that means minimum energy. So minimum energy you will associate it with what? You will associate it with water. Though water is more strong field than chlorine, but with chlorine here we have total 5 ammonia. So obviously D should be associated with minimum energy. That means maximum wavelength. So maximum wavelength means it should be 600. So D is 600. That means D is 4. Fine. And what about, so D is done, C is done. Now we are left with A and B. Now in among A and B, in case of B, you have ammonia. Here you also have chlorine. And it is associated 3 plus. That means the next higher energy should be for B. And we are left between these two, 475, 535. And as it is high energy after C, so it should be 475. That means B is 2 and A is 3, only 1 is left. So this should be the correct option. Okay. So in this way you have to approach it. Just look at the oxidation state, look at the strong nature of the ligand, whether it is strong field and weak field. And not just strong field, weak field ligand recognizing is enough, because ammonia, CN both are strong field. That is towards strong nature, but cyano is more strong, so that is you have to give preference to it, and that is why this will be the associated with maximum energy. That means 310 lambda. Next question. Which of the following cannot be explained by crystal field theory? Now here we have some statement. We have to choose that one which we cannot explain by crystal field theory. The first is the order of spectrochemical series. Remember the spectrochemical series, I have already shown it in one of the problem. And there you have seen there is some order. Starting from strong weak field, gradually we are moving towards the strong field. But how we are getting this order? Can you explain it from crystal field theory? That is the question. Then we have magnetic properties of transition metal complex. Now we can explain it by crystal field, because remember we have already solved some spin only magnetic moment question where you have seen where the n value is high, then in that case this spin only magnetic moment formula that will also be very high. That means from crystal field theory you can understand how many unpaired electrons are there. If you know the unpaired electrons, you can also understand the spin only magnetic moment. That means magnetic property you can explain. Then what about the color of metal complex? See, the last problem what we have discussed, wavelength. So when you can decide wavelength from crystal field theory, obviously you can have some idea about the color. Stability of metal complex. Now stability of metal complex, which is thermodynamics, related to thermodynamics, that is thermodynamic stability we are talking about. Then from del O value, when the value is high, that means it will be more stable. That means all these you can explain. But order of spectrochemical series. Suppose we are saying that cyano is strong field, water is weak field. But why it is so? The actual explanation we cannot get from crystal field theory. Though we use it to answer some question of crystal field theory, but what is the actual reason based on which this series is made? That explanation we cannot get from this. Crystal field theory introduced a spectrochemical series based upon the experimental values of del, but it cannot explain its order. So whatever series you see, it is always the experimental value, not any explanation you are getting from crystal field theory. But the other 3 points, which points? 2, 3, 4, these 3 options you can explain. And remember, when there is high CFSE, that means those complexes tend to be thermodynamically more stable. So if 2 complexes are given, you can compare simply the CFSE value and you can predict which one is will be thermodynamically more stable. So correct option will be the first option. Next question. The metal complex that is diamagnetic is, atomic numbers are given in the question as for information. Now why this is given? Suppose if you do not know that when iron is neutral, or suppose when iron is 2 plus, directly, it is better always if you directly can write. So when it is iron simply neutral, after argon configuration, it is 3d6 4s2. But when it is 2 plus, that means this will be 0. But why these informations are given? So that you can understand that after argon configuration, argon is 18. How many electrons are left? 26. 26 minus 18, that means 8 electrons left. So that is why it is 3d6 4s2. So these informations are extra. If you can want to use it, you can use it. But what we have to find? We have to find the diamagnetic complex. That means we have to find that complex where you do not have any unpaired electron. Now for that, how we will start? You will start with the oxidation state. The first complex K3, that means if you remove K3, 3K plus, there will be 3 negative charge. Cyano is also negative. So here oxidation state is copper 1. In the second case, if you remove 2 potassium, there will be oxidation state 2 minus. Cyano ligand, if you consider 4 negative charge, that means here oxidation state is, it is copper 2 plus. Third complex, negative charge 3 minus, it is iron 1. Here oxidation state will be, sorry, it is 4 negative charge. If you remove K plus, 4K plus, so it will be iron 2. Now when it is copper 1 oxidation state, now the configuration after argon, it will be total under neutral condition 2 plus 9, it is 11. But there will be total 10 electrons, 3d10. So 3d10, it is fully filled configuration. You cannot have unpaired electrons, so the n value is 0. So that is why it is actually the correct option. Fine. But for extra information, we'll also see what about the other one. When it is 2 plus, it is basically 3d9. So when it is 3d9, there will be unpaired electron. Okay. So Cu 2 plus, and then we have iron 1. So when it is iron 2 plus, we have it is 3d6, but here it will be 3d6 4s1. You can bring this electron in 3d, so it will be treated as 3d7. But we have already found our answer, as there is no unpaired electron. So this will be the correct option, and as it is single choice answer, so you can easily choose option A as the correct option. You don't have to waste your time for rest of the complex. And the last one, that is Fe2 plus. So this will be 3d6. You can also write the detailed configuration in that is, these are 4 coordination. That means tetrahedral, or it may be square planar also. Both chances are there, but you don't have to waste time in writing the electronic configuration because we have already obtained our answer. Diamagnetic complex. Okay. Now here you can see 2 questions together, but why it is so? Because both the questions are of similar type. So this came in 2022, and the second question, that is basically 2020. Okay, so see the similarity. The first question is correct formula of the compound which gives white precipitate with barium chloride solution. That means barium chloride reacts with what? Barium, it reacts with sulfate ion. So if there is free sulfate ion, there will be BaSO4 precipitate. BaSO4 is highly insoluble, so precipitation is possible. It is also saying that there will be no precipitation with silver nitrate. Silver nitrate, you get precipitation when there is Cl negative. Why? Because AgCl is formed, but AgCl precipitation is not possible. That means free Cl minus is not present. So this is the meaning of this question. And what about the second question? It is saying that a complex have molecular formula like this. When formula is given in this way, you do not know which ligand is directly attached to metal, which is outside the coordination sphere. So it is given in this way, but it is also saying that the aqueous solution of it gives white precipitate with barium chloride, just like the previous problem. But no precipitate is obtained when treated with silver nitrate. See, same information, only it is given in a different way. Just compare these two. If the secondary valency of the metal is 6, that means it will be attached with 6 coordination within the second bracket. And primary valence means the actual oxidation state. Secondary valence means the coordination number. Which one of the following correctly represents the complex? So as there is no free Cl, but there is free SO4, that means SO4 should be outside the coordination sphere. Now if SO4 is outside the coordination sphere, that you can have in this complex, right? And here we have total, look at the formula, 1 sulfate, 1 chlorine, and there is 6 water. Now secondary valency, it must be maintained, which is 6. So comparing all this, here it is 6, here it is 6, here it is 3H2Cl, so it cannot be correct. Okay, and in the option B, the Cl is missing, so this is also cannot be correct. So this is the only option that is possibly correct. What come to the first question? Here nothing is mentioned about the secondary valence, but it doesn't matter, you just have to check. Oh, okay, here formula is slightly different. In some options it is Br, in some options it is chlorine, but whatever it is, sulfate, free sulfate must be there. So sulfate must be outside, so it is matching with this. And as it is not giving any precipitate with AgNO3, that means free Br or free Cl minus, they cannot be present outside. If you are choosing these options, that is any of the options B, C, D, it will be wrong, because here sulfate is not outside, either the Br minus or Cl minus outside, but that will give you precipitate AgNO3. Basically the first question is comparatively simpler than the second one. So here option A will be the correct option. Okay, so we are already running out of time. Only one question I will finish. Here we have again two statements. The first statement is nickel CN4 2 minus is square planar and it is diamagnetic complex with DsP2. Now when there is strong field ligand, there is chance of square planar complex formation rather than tetrahedral. So this part is right, correct. And it is saying diamagnetic because here it is 2 and nickel 2 plus means what? It is 3D8 and there is cyano ligand. That means it will be having, okay, let me write it like this. So it will be basically, that is all the electrons, they will be paired condition. And it is, sorry, it is octahedral. It is not octahedral, it is DsP2. That means you can write it in this way. DsP2 means if it is 3D, all the 4 electrons, 8 electrons you have to write like this. And after that there is 4s and there is 4p. So DsP2 means 1d, 1s and 2p. And rest of the 8 electrons it will be like this. So this statement is correct. But what about the second part? But NiCO4 is tetrahedral paramagnetic with sp3 hybridization for nickel. Yes, it is true, it is tetrahedral. It is having sp3 hybridization. But is it paramagnetic? CO is neutral ligand. That means it is nickel, zero oxidation state. That means there will be total 10 electrons and all of them will be paired. So it is not paramagnetic. So this statement is partially correct, not fully correct. What about statement 2? It is saying that nickel Cl4 2 minus and nickel CO4 both having same d electron configuration, same geometry and are paramagnetic. But we have already seen this is not paramagnetic. And the electron configuration cannot be same because CO is strong field ligand. This is not strong field ligand. Okay. So the net conclusions we can draw like this. The part there is mention of total 3 complex. This one, and this one. Nickel with cyano with carbonyl and with Cl. So it is D8 strong field ligand. It is square planar diamagnetic. First statement is partially correct. This is D10 SFL. That means strong field ligand. It is tetrahedral, but it is diamagnetic. It is sp3 hybridization. That means in 3D, all the 5 orbital there will be pair of electron. It is D10. And nickel CL4 it is D8 because it is 2. It is tetrahedral. So see, both are paramagnetic. This is not correct, but it is tetrahedral. This point is same for both these complex, but this part is not same. So both the statements are basically false. So option B, that will be the correct option. So we are ending the session here. Thank you for listening.